Today, I'm going to be talking about analyzing a malicious Android APK with Ukrainian military themes. So, on the backdrop here, you can see the classic designation of bytes for hybrid analysis sandbox outputs. And this sample was found by me. As far as I know, no one else has reported or discussed this on the open source world, as far as I can find. Please do tell me if I am incorrect on this. And this is looking at a sample that I think is fairly unique when it comes down to current interest in threats related to Ukraine, Russia, and the conflict that we have since 2022. This sample is available on hybrid analysis. This is not available on VirusTotal, which is a little bit rare, but this is where we're at. And it was a sample that I queried and hunted for and found of interest. So it was identified on the 26th of February 2025. We've got here sort of the somewhat Delta theme, what they're going for on the file name that's of the submission. The interesting thing is the no specific threat. So the sandbox from hybrid analysis did not find this a threat at the time. And from my current understanding, all of these static detections from the AVs that were on MetaDefender did not find this. Obviously, not being on VirusTotal might be a little bit different, but it's not. It's on hybrid analysis. So designated a clean at that current point. However, I disagreed with that analysis. I thought at the time, looking at static output from the sandbox, that it looked very like it was going to be malicious. So I decided to dive a little bit deeper. No one else had looked at this. There wasn't any indications of a C2 at that current point. The C2 wasn't really in any static detection strings or anything like that. There was only the permissions it was asking for and slight remnants of sort of the imported libraries and what it wanted to include in this particular threat. So we'll walk through it all. It'll make more sense in a moment. I'm just thinking back about the bare basic bones details of the file. So let's talk about the file for a little bit. So we've got the file name. It didn't have to be that big, as far as I understand. There was a choice, or there is a little transition maybe by the threat actor related to this. What is Delta? It's a situational awareness and battlefield management system developed by the Ukrainian military. Do I fully understand what that is? No. However, it does seem to be important in the lens of military, battlefield, war, conflict, however you want to say it. It's a system that at this current present time is of interest for Ukraine. They use it currently in their conflict. And I think this is a screenshot of it. I'm not fully sure because it's, as far as I know, a tightly guarded secret where they utilize it and they may allow other militaries to use it. But at this current present time, I believe they are the ones that are only using it. It upholds to some NATO standards. So it possibly could be, but the whole point of it is a Ukrainian technology. And so without putting too much sort of bias or emphasis on it, there is obviously clear motivations for other powers such as Russia that may be interested in understanding or getting access to this, or the people that are around this sort of system for obvious advantages on the battlefield, to military intelligence and intelligence overall. So the theme itself is of interest overall. Delta is a interesting concept in itself in its current present time. The file was submitted on the 26th of February 2025, so fairly recent when we think of it. So when we think of Delta overall on themed attacks, so this isn't the first time. There is Still Deal Fake Grab, which is a variant that CertUA have called out in 2022. If people are unaware, CertUA is Ukrainian's CERT, Computer Emergency Response Team. Hopefully I got that right. And essentially they often provide updates via their blog on attacks that they have observed in their network or where they are able to help in defense. So they are very much, if you want to research or understand what Ukraine and other countries are comfortable with releasing openly, you can see it through Cert UA and translate and look at all of those threats. So it's a really good resource to identify. And in 2022, we saw that it was a Delta themed piece of malware related to certificate updates. That was the lure, the understanding. Still deal fake grab is a variant that was used that you can attribute to a certain threat actor or at least a piece of activity. Between 2022 and 2025, we've had a lot of Delta themed phishing, be that multiple threat actors or whatever. We've seen pages that look a lot like this. This is the opening page for Delta, but it has been copied and phishing attempts have been made to it, which would make sense when it comes down to a conflict and it being a platform that is related to military intelligence. You would expect that, but that's been happening for a very long time. And in 2025, we've got the Android app that's compiled in 2025. So this isn't the first, that's the framing of this slide. And this isn't probably all of the attacks. There's a lot probably in closed source channels, but I thought I'd just give a little overview of things that are available in the open source and something that maybe people aren't aware of that don't follow threat intelligence, or at least this area of the world when it comes down to threat intelligence. This is the signature details. The whole reasoning I was putting this in is actually to just give it a little bit of a timeline. So obviously when you're looking at portable executables, you can understand maybe someone's modified the timestamp, and this is possible. It's highly unlikely, but it is possible there could be some modification here. You get a lot more modification on the portable executable when it comes down to timestamps, but forensic remnants that allows you to give a timeline of attacker activity. So that could be, you could understand when the C2 came up or when technologies on a C2 service occurred, but you can also look at the actual file, the metadata within the file. Often you'll have attackers that misplace metadata or don't fully understand the compilation process, and you can work through that. In this case, it is kind of valid, and I think it's fair for us to say that this is a probable valid piece of metadata that we can see here, where we've got the validity set to the 14th of January 2025. This is likely the compilation time or around about the compilation time of this Android application. This is the debug. So it's sort of, it's self-signed, I guess. When we think of certificates like TLS on websites, you can have self-signed certificates, but then you need to work out a certificate chain. It's very much similar to this when it comes down to it. So this would have required the person who they were trying to target to actually try, say, developer options, use self-signed certificates, it's fine for this application. So they would have had to make multiple steps. This isn't the first time we've seen this, and I'll talk about that a little bit later, but just a little detail on timeline being in January probably. And also they didn't expect the target or the victim to download this on the Google Play Store. They were expecting to do this, in quotations, out of band. So this actually is this piece of malware likely related to this forum post. This is from a person called NMZ in this forum post from 2023. Often you do see this by threat actors that need to utilize different threats quite quickly, and they feel that they have a level of comfortability in a certain part of source code, or they feel safe in these certain areas, and so they'll utilize stuff from forums or communities that they are from. In this particular example, as well as that, it can also be incredibly non-attributable. You can have it online, so it cannot be attributed originally to this particular threat because it was originally attributed elsewhere, muddying the waters a little bit. The left here, we've got a forum post outlaying this sort of template of what this malware is, which is essentially it's requesting internet access, the gallery, and file storage. They open up the permissions a little bit here. This has only got 2. This is essentially a gallery stealer, and it uses raw sockets to basically send pictures from the phone to a C2 server, which is a basic Python raw socket server. This is what the message that the victim may get when it comes down to it. And the project is called Ghoul Grab. And we've got NMZ, the person's name there. So this is quite interesting because this is likely the template that was used by the threat actor, and then they sort of formulated it and changed it slightly and have used it, which is not unheard of if you think of PlugX, which is quite famous nowadays. And I've actually outlined in my previous presentations on this channel. Yes, this is the original source from what I could deem when looking through. So what's in the Android manifest? Well, we've got a couple of things. We've got the XSS NMZ call grab. I do call out in the blog posts a bit more about this, but the big thing here is the call grab, which allows us to link back to this particular forum posts. We do have the permissions, as we can see from the previous slide. We've got read media images, we've got internet. Here we've got internet, read external storage, and read contacts. So a little bit different. The difference between this malware is that it actually iterates through their contacts, their files, their videos, and their images. So they're a little bit more interested in certain things. They have a number of different references to NM Ghoul Grab, as we can see. This is the Android manifest where you would expect the permissions to be defined and for the entry point to be defined, which we have here being the main launcher. So it gives you a little bit of detail of what to expect, how it's launched and what's going on, what icon it uses. It was using a sort of generic, what you would expect a crime group to be doing, crime threat actor rather, a sort of PDF-like lure icon, which was quite interesting. We've got imports here. There is a disparity in what's expected, and there's a conversation to be had here. So they don't use raw sockets. They do use HTTP, but they don't use OK HTTP3. They use the Java native HTTP. Now, I am unsure whether the decompilation process has stripped down and then just shown me the raw bones of this, or in actual fact, the decompilation is so good it's actually noticed that the threat actor has imported a library but has never used it. So definitely this Kotlin is used throughout. It's sort of the framework and what likely the threat actor utilized to be able to do it. So I'm a little bit hesitant on the decompilation results from my side, but this is what it looks like. And I can talk generally about the detail, but it's just a little bit of a disparity between the decompilation and what was expected from the libraries that we saw within it, and why it was 8 megabytes, which is the talking point I wanted to say, is that we've got a lot of different expected things that are going on here, but these two are sort of a little bit strange. So something to think about. There is quite a lot to look at overall when it looks at the sample, sort of why the threat actor made these code changes, but in the sample. But I actually don't think that's sort of the remit or what I should be talking about in this presentation. I don't think it's of interest, but just wanted to outline. It's a big boy, and there is some disparity in the decompilation of what you actually see. So permissions. What have we got going on here? Well, essentially, it's checking for the permissions. It's really interested to make sure that it gets the right permissions. So it will, on create, it will attempt to identify through a single threaded executor whether it has the correct permissions. Context compat, which you might have noticed here, it goes through there as a method to be able to check that it's got the right the permissions. If it does, it goes to the main method that it's interested in, which is start the tasks and zipping them up and sending to the C2. If you go out of the context, it also has it brings it back into the context here, where it will then check through here on request permission result that it receives that it has the correct amount. If it doesn't, it looks to silently fail with a log. Which I assume was during the testing of this, but they've just left it as that. So the main thing here is we can see start zip and send task is the one to know. There is quite a lot of different code that I could go through, but actually I want to keep this short and snappy. It does iterate through every image, every file, and every video, as well as every contact. It will save them up and put them into a zip, and they'll start sending them via a C2 via HTTP post, which we'll see in a moment. The big thing that's quite of interest is that it actually checks when it goes to the file checks that it has these particular folders. These are the folder directories that are, or the direct folder or directories that it is interested in. It'll add them into a little array. It will check if there are no files, media, images, and then it will silently fail. So say it could be a sandbox or something like that, it will fail, which I suspect might be the reason why it failed for the sandbox on hybrid analysis. I'm not fully sure, but that's my theory. And we've got here interesting things in the sense that it is looking for downloads documents. I'm not fully sure what ArtMap is, but that's the interesting thing from the folders. There's more context and more understanding from the blog post. So just putting it out there on what that is. And this is what the C2 looks like. So after you've zipped it all up, it will use the Android cache directory, which is sort of deleted over time when it needs disk space. So it's sort of used as a temporary directory. It will store these zips in the same file name, and then it will send it over via HTTP post, as we can see here. So we've got a Ukrainian IP and this a non-standard application port, and it will be expecting a HTTP server response. It'll be sending a post with the file name, and it will do it over chunks of a megabyte to the buffer. So fairly simple, but not using the raw sockets that the original project used. This is from the threat actor, we presume. We can see some debug messages that it is attempting to push out here to work out what's going on. Lots of catches just to make sure. Clearly had some concerns or worries that there would be breakages in some sense, but that's the thing. So is this the first time an Android application has had Ukrainian themes? No. Or Ukrainian military themes? No. So in 2016, we had Fancy Bear, who were tracking Ukrainian artillery, I should say. And then I can't remember when this was, but this was between 2022 and 2025, early 2022, 23, I think. There was activity related to cyber Azov, where a Russia-based threat actor was attempting to get Ukrainians to download this particular application so that it would execute as well as malware. And it was during the conflict, so it isn't the first one to be, but it is similar in the sense that it's an Android application with Ukrainian military themes. So it's got a timeline. It's like everything else that we've got going on here. It has some form of timeline. That was a lot of slides to go through. And I believe that is it. Thank you very much for listening.